Hello everyone. Today we're going to see uh, temperature control using 8085 microprocessor. Consider a heater is there. It has to maintain the temperature of the water should be 40 degrees Celsius. Just for the example. Okay. That 40 degrees Celsius is already programmed in 8085. So 8085 should be the responsible device, should take care of the temperature of the water which is maintained in the heater. Accordingly, the heater has to be controlled by the 8085 microcontroller. So here, whether the heater should turn on, whether the supply should be given to the heater or not, will be decided by this relay. Okay, normally open, normally close relay concept already you all aware. So this relay will be given supply with the help of this transistor. If this transistor is turned on with the help of the signal from the 8255. The 8255 is controlled by microprocessor. So microprocessor, if it decides to give the signal to the 8255 to turn on this heater, which will send the signal to 8255, then the 8255 will send the signal to turn on the transistor with the help of base signal. So that once the transistor is turned on, then this coil of the relay will be energized. So if it is energized, that means it will be what attracted towards normally open. So as per the signal from the 8085, this relay is operated accordingly. The heater is turned on or turned off. Okay. So consider at present the heater needs to maintain the temperature to 40 degrees Celsius. Okay, but at present what the water available inside this heater is 38 degrees Celsius. Still it has to heat. So if it has to heat means it is closed. So normally closed condition. Normally closed condition means the supply through this closed switch will reach the heater. So the heater is keep on heating the water available in the heater. So once if it reaches 40 degrees Celsius, consider 40 degrees Celsius, that will be sensed by the the physical quantity to be measured. Physical quantity to be measured is the temperature available in the water which is available inside the heater. That is a physical quantity to be measured. Consider it is reaches a 40 degree Celsius. Once if it reaches 40 degrees Celsius, I should turn off the relay. That means it is an automatic switch. I should not apply the supply to the heater because it reaches the required temperature. So the physical quantity to be measured is the temperature level that which will be sent to the transducer. In measurement and control subject, you would have studied about the transducer. The transducer is nothing but a device which will convert any physical quantity. Any physical quantity means water flow, at what speed it is flowing, whether flow is there or not, and similarly atmospheric humidity, and then the temperature, everything. These are all called as physical quantity. That physical quantity we will be we used to see in some display like 30 degrees Celsius, 40 degrees Celsius, but around us that is not visible, but it is converted as a digital value around us. The temperature we are not able to see with open eyes. How that digital display is showing, like this is room temperature, this is the temperature available in the fridge, like that it is mentioning in digital display. So that process only we are going to see here. So this physical quantity, nothing but the temperature inside the heater, that is given as an input to the transducer. The transducer which will convert that physical quantity into electrical quantity. Okay, but that electrical quantity which is low in magnitude, very low. After conversion, physical quantity into electrical quantity out of the transducer, that level is very low. for the A to D converter. So A to D converter, whatever the data which is coming out of the transducer, which is nothing but analog value, that analog value need to be converted into digital. Then only the digital signal can be given to the microprocessor via 8255. Then only the microprocessor will understand, okay, this is the heater temperature and the required temperature by the user also same. Then we should turn off the heater, like that. Then only the microprocessor will understand, accordingly it will give the signal via this. Okay, until the microprocessor don't understand, it will not give the signal to turn off. So unnecessary power supply waste. So ADC should need sufficient level of analog quantity to convert that into digital quantity. So to have a sufficient level of analog quantity, we will be using instrumentation amplifier. That instrumentation amplifier which will convert the analog value which is coming out of the transducer to a higher level of higher magnitude of analog voltage. That value will be given to the ADC. At present, analog to digital converter is having analog value. It is ready to convert, but it will not start converting immediately until it is receiving the start of conversion. Already you all aware about ADC in start of conversion in ADC and end of conversion in ADC. So that the ADC should get start of conversion. Why? When the start of conversion will be received by ADC means if the microprocessor is going to monitor the heater temperature, means it needs digital data. So it will send a signal, send me the digital data, like that it will send a signal to the 8255 to ADC. So ADC now it will convert the available analog value which is coming out of instrumentation amplifier. That analog value, if it is get converted into digital, then the ADC converter will inform to the 8085 with the help of signal called end of conversion. That means analog values got converted into digital value. Now you can get the data from ADC to processor. Once the ADC sends the end of conversion signal to the 8085, 8085 will start receiving the data from this port. Okay, so port A will receive the data. What data? Digital data. The digital data will reach 8085. Once the 8085 receives the digital data, already required temperature is 40 degrees Celsius, and at present heated temperature, water temperature also reaches 40 degrees Celsius. Then no need to turn on the heater further because already it reaches 40 degrees Celsius. So what microprocessor will understand? 40 minus 40, so 0. So no error. No error means no need to give continuous supply to the heater. It will send a signal via port B to reach the transistor. The transistor, if it get turned on, this coil will get energized with the help of this 5 volt. Once this coil is energized, this portion of the switch will get attracted towards a normally open condition. So if it gets open, you can see this switch is got to open, means this supply will not reach the heater. So once a particular temperature reaches, the heater is get turned off with the help of continuous temperature monitoring of 8085. Okay. I hope you all understood this temperature control using the processor. This can be utilized in room cooling temperature also by controlling the AC supply, air conditioner supply. Thank you.